If you're going to count, you have to start from 1. You get the next counting number by adding 1. You literally could count forever. But how do we use this idea? What if we break each number down into its collective ones? Because they're just a set of ones, we can order them any way we like. And because we can order the ones any way we like, this means that we can literally flip the numbers in the sum. We call this ability to flip numbers around in a sum the commutative property of addition. Also, the sum of the ones gives us 9. Note that every one of these lines results in the same thing. Because of this, these expressions are called equivalent. The commutative property and equivalent expressions are concepts that will become very important as we move forward in math. Now, let's consider a larger sum. Think of this as starting at 0 and going 47 steps to the right, and then continuing 52 more steps. This would be the same as starting off at 0 and just going 99 steps to the right. In essence, this is how sums work. Likewise, with this sum, it would be like starting at 0 and taking 47 steps to the left, and then proceeding 52 more steps to the left. This would result in the same thing if you started at 0 and just simply proceeded 99 steps left. Trouble begins for most students when we are introduced to numbers with different signs. The number line is also handy here. Based on our previous instructions, this would tell us to start at 0 and go 52 steps to the left, and then return right 45 steps. The end result would be the same as starting at 0 and going 7 steps to the left. This perhaps brings us to the first set of confusing rules students run into in school. The way that math is taught now, they say if you add same signs, add and keep the signs. If you add different signs, subtract and keep the sign of the larger. Using the number line, this is a much simpler idea. Starting at 0, same signs, same direction. Different signs, different directions. This way, whether you keep an image of the number line in your head or draw a quick sketch of one, you can always get the answer you need. This way we can quickly go from 0 to negative 41, then go back 60 places and end up at positive 19. This is the same thing as starting at 0 and going 19 places to the right. And note, if we keep the sign with the number, we can still commute these and get the same result. Note that I didn't put a plus in front of the 60 in the second line. I could have, but we don't normally do that. It is vitally important that you remember though, when you commute numbers in a sum, the sign must go with the number. I think that it is important at this point that I introduce a special case of sum, when we add a number to its opposite or additive inverse. The result of adding a number to its opposite is always 0. This is going to crop up again when we come to solving equations and will become very important in that process. Before we end the video for the day, I would like to take a look at a slightly more complex problem. By color coding, I get a better idea of what I have to work with. I could go from left to right and simplify this problem that way, but I'm going to try getting my negative and positive numbers together first, using the commutative property. Now that we have the negatives and the positives together, let's go from here. When we add the negatives, we get negative 136. Now let's combine the positives. When we sum these, we get 80. The end result is negative 56, which would be equivalent to starting off at 0 and going 56 steps to the left. So whether you add the values two at a time or group them by signs and then add them, your results are going to be the same. Thank you for watching my video, and I hope that it was helpful. Next up, we will look at order and absolute value. Until then, we'll see you later.